On section 9.5, we are looking at standard 16.0, and we are going to be graphing and writing equations of hyperbolas. Now, the definition for a hyperbola is the set of all points such as the difference from P and two fixed points is called a foci, and the constant remains, or the difference is constant remains the same. Now, for now, let's just go into the different figures that we have. Go and write down both equations. Notice that they're very similar. We also have a vertex, same as an ellipse, and we also have one focus and another focus. If the x is first, is positive, or just written down first, that means that your hyperbola is going to go sideways. And be sure that to draw two arrows because the hyperbolas will continue. If your y's are first, that means that your hyperbola will be up and down. And same thing as before, we have one vertex, one vertex, one focus, one focus. These ones, we used to call them covertices, but because they're not part of the graph, we are not going to label them. Now, the foci of an ellipse lie on the transversal axis, that is on the actual one where they're facing. And if you guys can fix it, this should be a plus in between. Very similar to the ellipse, but now it's going to be an addition. Things that you need to keep in mind is that A is the distance from the center to the vertex. B is the distance from the center to the covertex, even though it's not part of the graph, but we're just going to call it covertex for now. And C is the distance from the center to the focus. So from the center over to the focus. Now let's go and look at example number 1. On example number 1, we want to be able to draw the hyperbola. Now notice that on the previous the formulas, we want to be able to make it equal to 1. So same thing that we did with the ellipse. In order to be able to make it equal to 1, to be able to have it on standard form, we're going to divide by 36 on both sides, on each of the terms. By dividing by 36, it's going to be equal to 1. Now, we want to be able to reduce our fraction. So one number divides 4 and 36. We can divide by 4. So it gives us 1x squared over, divide by 4 gives us 9, minus, divide by 9, so that'll give us y squared over 4. Now, we want to be able to graph it. First thing, now that's in standard form, we want to be able to find the center. The center is found by h and k. And as you guys notice, there's no h and k, so it will be 0, 0. Your center will be at the origin, and this will be your center. Now, under the x, there's a 9, so the value of a will be the square of 9, which is 3. It's under the x, so that means that we're going to go to the right 3 and to the left 3. Under the y, there's a 4, so the value of b will be the square of 4, which is 2. Since it's under the y, that means that we're going to go up 2 and down 2. This will help us shape the diagonals. So I'm just going to find the corners. One here, one here. The corner will be here, and the last corner will be here. We are drawing the corners to be able to help us draw the asymptotes. And the asymptotes will help us guide us through the process of drawing the hyperbola. So this is the first one. And this is the second. Now that I have drawn my asymptotes, I need to be able to decide if my hyperbola will be going sideways or will be up and down. To determine that, I'm going to look and see which one is positive or which is written first. In this case, that x squared is positive, is the one that's written first. So that means that it's going to be going sideways. Now, when you draw it, you want to be able to use this point. This is your vertex, and we're going to get closer and closer to the asymptote, but we're not going to be touching it. So from your vertex, we are going to get closer and closer to the asymptote, but without touching it. Now on the other side, from your vertex, it's going to get closer and closer to the asymptote without touching it. And from your vertex, getting closer and closer to your asymptote without touching it. Remember to label your vertex, so that's your vertex. Now I need to be able to find my focus. So in order to be able to find my focus, I need to be able to find C. Remember, C is the distance from the center to the focus. So once I find C, then I can take the distance and locate my focus. We're going to use the formula above. C squared is equal to A squared plus B squared. C squared will be what we're looking for. A squared will be 9 and B squared will be 4. I'm going to simplify. So C squared is equal to 13 and C is equal to the square root of 13. So now that we have so now that we found the value of C, which is square root of 13. Now, square root of 13, it's approximately is between square root of 9, which is 3, and square root of 16, which is 4. So square root of 13 it's closer to 16. So let's go approximate to 3.7, 3.8. Now remember that your focus will be inside the hyperbola. So it will be on the same axis as your vertex. So we're going to go to the right, 3.7, 1, 2, 3.7, and that'll be your focus. And to the left, 3.7, and that'll be your other focus. Now, one last thing that we need to do is to be able to find, we need to be able to find the equations for the asymptotes. So to be able to find the equation of the asymptotes, we are going to go back to the formula that we learned in Algebra 1, which is the point-slope form. And it's y minus y1 is equal to mx minus x1. I'm sure all of you remember this formula. And in order to be able to utilize this formula, we need to be able to find a point on the line. Now, because I want to be able to go and do both lines at the same time, I'm not going to use where they intersect, which happens to be, of course, the center. So I'm going to be using that formula for that point for both equations. So let me go and substitute. I'm going to substitute it here and here. That'll be y minus 0 is equal to, I'm going to hold on to the slope, x minus 0. My slope for the equation is up 2 and to the right 3 because it crosses those 2 points. So my slope of this line is up 2 and to the right 3. So it'll be 2, 3, and if you notice, one of them is positive slope and the other one's negative slope. So we're just going to do plus or minus. We really don't need the y minus 0 just y, or we can just think of this as y is equal to plus or minus 2 over 3, and x minus 0 is just x. And this is the equation of the line. One of them with a positive slope, the other one with a negative slope for the asymptotes.